5 of this tutorial class. Please, as usual, don't skip any part of this video if you must take full advantage of this particular aspect of our tutorial class. Guys, in this tutorial class of today, we are going to be looking at complex surds. Yes, we're going to be looking at the concept of complex surds. Like I explained before, complex surd is an aspect of surds where we use multiplication and division. So it is an aspect of surd that is termed under multiplication and division of surds. So we have question number 1 on the board, we have question number 2 on the board, then we have question number 3 on the board, a combination of both. We are going to solve more problems, like we're going to solve 6 problems under this, then before we go into the aspect of deep rationalization of what? So now, at this point, guys, what do we do here? At this point, this is solution. We have root of 45 times root of 28. Under this aspect of multiplication and division of surds, there are so many things you need to know. So many. There are so many ways you can solve it. Numbers of ways you can solve it. First, this question looks like rule number 1, right? Where we have root A times B. We said it can be root A times root B. And we said from the beginning that this is equivalent to this. It's vice versa. It is either you are giving like this to express it to this form, or given like this to express it to this form, as the case may be. So now, as it is here, I can decide to solve these ones individually, like we were solving other addition and subtraction. Now, so you can decide to simplify this to its least surd, also simplify this to its least surd before you multiply, or you can decide to just multiply direct now, bring them under the same square root, and say 45 times 28. Now, I will tell you the reason why we will go for 1. Method 1, simplify this to the least surd, simplify this to the least surd before you multiply. This is method 1. Then method number 2 is to use the rule number 1, which says that you can just multiply them directly. You will still have the same result. Any of the method you use, you are going to have the same result. But there is a disadvantage in using rule number 1. What is the disadvantage? The disadvantage is that you cannot solve this effectively without the use of calculator, or even though you are not using calculator, it will take you time to multiply out this large number. So it will be easier for you to reduce this number to the least surd first before you will now multiply finally. You see, I hope you get the difference between the two. Here, you will need to use calculator because the values are large. But if you want to deal with them individually, you can deal with it without using calculator. Are you there? So me, I will prefer, because of the purpose of exam, I will prefer we look at a case where we will not depend on calculator. Are we there? Where we will be calculator independent. We are going to follow a track where we will be calculator independent. And in that case, that is a case where you treat them individually. Alright? So we will not use this. But like I said, you can always use this. You use calculator to multiply this, you can get a large number. Then you need to find the square root. That will take you much time. Now let's follow this method. So how do we split 45? Of course, for various videos you have done, you already know how to split, how to reduce large surd to a simple surd. So 45 would have given us 9 times 5. 1 must be a perfect square, as you have explained, so this shouldn't be a problem to you. Then times, we are separating the 2 terms. This would have given us what? 4 times 7 will give us, of course, 2 times 14 will give us 28. Then 3 is not a factor of 28, then the next is 4. So 4 is a perfect square, so that is why we go for this. Of course, I already know you understand what I am doing at this point, so I may not be putting everything into consideration again, because before now, I have already explained in details what you do when you are simplifying individual surds. Okay, so at this point now, 9 is a perfect square, so I'm going to have 3 times root 5. The root of 9 is 3. Times root of 4 is 2 times root 7. So this would have given us 3 root 5 times 2 root 7. This is it. The next thing you do, so now, at this point, what we simply do here is to now say, okay, 3 times root 5 times 2 times root 7. So what do we do here? We will bring together the numbers without square roots, and we bring together those with square root. So this is going to give us 3 times 2 times root 5 times root 7. Hope you see this, guys. Yes. The next thing we do is this times this, guys, will give you what? 6. 2 times 3 is 6. And this will have given us root of 5 times 7. So it is at this point now we now adopt this rule. Of course, we know that we can multiply 5 by 7 without the use of calculator. Of course, we still use this. Yes, definitely you are still going to use this rule, but at that point when you will now be using this rule, the values would have been reduced to the minimal point whereby you can multiply the values without the use of calculator. Alright? So we prefer this. Then this will have given us 6 root 35. 5 times 7 is 35. This is the answer to this. It's as simple as this. When you use this, it may make the step much easier, but what happens when you are in an examination where calculator is not allowed? That is why I prefer this. But if you have a calculator, you can try out this with the help of your calculator. Now let's get started. There's question number 2. Guys, we are asked to simplify 24, root of 24 over what? Root of 50. The same way we can simplify this individually, also simplify this individually. Before we now use rule number 2, number 2 states that if I have a square root of a over b, where both a and b are positive, that this can be simply subdivided into root a over root b. Now it came in this form, and that means you can simply convert this to this form, right? Yes, it's possible. Then we divide that. But I will prefer that we go through a process where we can just deal with the numerator separately, deal with the denominator separately, then finally we can use the square root if we have it. We can convert from this form to this form. If it is possible for us, like I said, there is no one way to do it, alright? It's a matter of choice. But let's be used to one method of simplifying each term or each sort first before we now simplify their relationship, right? Now, at this point now, we know that 24 would have given us what? 4 times 6. Of course, we have looked at 24 before, right? Now, also when we come to 50, 50 would have given us what? 25 times 2. This is it. It's as simple as this, guys. So now, we already know that 4 is a perfect square, so we are going to have 2 times what? Root 6. Why this would have given us what? 5 times root 2. The square root of 4 is 2, and the square root of 25 is 5. The square root of 5 is root 5, and the square root of 2 is root 2. Now, what else do we do here? We are going to have this as 2 root 20. Sorry, it's 2 roots 6 over 5 root 2. Okay, now that we have reduced this number, we can now collate this. We now have this 6 and 2 inside one square root. And how do we do that? This will have given us 2 over 5 all root 6 over 2. Using the rule number 2, which says a over b is equal to root b, a over root b. It's as simple as this, guys. As simple as this. Now we know, of course, that 6 is divisible by 2. So when we divide 6 by 2, guys, we are going to have this as 2 over 5 root 3. This is the answer to this question. As simple as this. As simple as this. So simple. Simple as this. Okay, guys. The next thing we are quickly going to do now is to look at question number 3. Now, in question number 3, we are given root 60 times root 108 all over. Okay. In this question, we are given root 60 times root 108 all over root 75. Guys, like I said, you can use the direct method, which we enable you to be using calculator. You need to use calculator by collating this inside one square root and multiply 60 by 108 using rule number 1. Then finally, you now use rule number 2. You now connect the square root here and this together. But we don't want to follow that process. Like I said, it is still possible to solve it that way. Should the case you have learned from another tutor before and he taught you that method. Now we come in this way, you say, we're not taught like this. No. That's why sometimes it's good you stay to one method first. When you get used to it, then you can begin to learn other methods alongside with it. Because you shouldn't learn one way of having things done. You should learn, yes, multiple ways of doing particular one thing and getting the same results. You should get that. But when you are just a beginner, just first of all, build yourself and get used to one. Then you can begin to learn others alongside. When you have already mastered one of the ways to have it done perfectly, right? Now, at this point, so let's review. So we want to simplify each of these to the least possible. And how do we do this? Root of 60 would have given us, guys, this would have given us what? Now, 60 divided by 2 would have given us 30. None is a perfect square. 60 divided by 3 would have given us 20. None is a perfect square. Then 60 divided by 4 would have given us 15. Then 60 divided by 5 would have given us 12. Then 60 divided by 6 would have given us 10. And 60 divided by 10. 8 cannot go, 7 cannot go, 9 cannot go, 10 would have given us this. So we have gotten all of this. So the only place where we have two factors whereby one is a perfect square is 4 times 15. So we just simplify and have this as 4 times 15. It's as simple as this. For this first term there times the second term. Of course, we have did 108 before. 108 is 36 times 2. Hope you remember that, yes. So we're going to have this as 36 times 3. 36 times 3 all over. Now the denominator here, which is 75, would have given us what? 25 times 3. It's as simple as this. So what do we do? At the numerator here, the square root of 4 is 2 root 15. Then times the square root of 36 is 6 times root what? 3. All over the square root of 25 is 5 times root 3. So you see now you are solving without the use of calculator. It's easy. But if you want to multiply 2, you need the use of calculator. The help of calculator. You cannot do it without the help of calculator. And even though you are not using calculator, you must use the multiplication table to have that done, right? Now, so at this point now, we are going to collate the numbers and also collate what? The rational numbers. So we're going to have 2 times 6 times root 15 times root 3 all over 5 times root 3. At this point, guys, all we need to do is to multiply the rational numbers. Okay? So we are going to have 2 times 6, that would have given us 12 times root 15. Now, guys, 3 can cancel root 3, yes. Root 3 can take care of root 3. So at the denominator, we have 5. Then finally, this will have given us 12 over 5 root 15. Is as simple as this. Of course, we cannot simplify the root of 15. It's not the perfect square. So we cannot find the root of 15. Because if we do, we are going to have a decimal numbers. And we do not need decimals when we are dealing with surds. So at this point, this is the answer to this particular question. So guys, we will head on to solving question number 4, question number 5, and question number 6 under complex surds, multiplication and division of surds in the next video. So if you have not subscribed, please do so. Ensure that you like this current video. Then you go down to the description below so as to find the link to the next tutorial video. See you guys in the next class, and thanks for watching.